Hi everyone, it's Mrs. Warner. Okay, lesson 3 on circles. I know you're super excited for this lesson this week. We have this lesson new, and then we have angles practice. Doesn't get any better. Hope you guys are doing well. Okay, so I have the whole completed note sheet in the Google Classroom again with everything filled out. And in honor of not making this video last for 25 minutes, because I'm pretty sure you don't want to listen to me for 25 minutes, you can look on the completed note sheet for some of the things to fill in. Okay, so for the first example, it's just a warm-up from last week's lesson where the opposite angles in the quadrilateral are supplementary. So if you want to practice that, you can. I'm going to leave that for you guys to practice. And then down below, the next thing says, oops, look at that. That's crazy. It asks, what is a tangent? And a tangent is just a segment that stems from the outside of a circle and it touches the circumference of the circle in one position. So if you look in here, GH tangent, or HG is a tangent in that picture. Why won't this move up? Okay, so here we go. So we have the angle that is formed by the tangent and a chord. Now remember, the chord is inside the circle and it touches it in two spots. So IH is the chord here. So if we're talking about angle H, the angle that is formed there by the tangent and the chord is actually half on the outside. So if you use is half the arc. So if you look at examples down here, it says solve for the missing angle or value. Okay, so see how this arc is 220? All I have to do is take half of 220 and 110 is how much angle 3 is. So angle 3 is 110. Half of the arc is the angle. Or if you take the angle and double it, it gives you the arc. You can work both ways there. Okay, let's try this next one. Okay, so 160 is on the other side, but I'm a genius because I'm in honors. And I know that 360 makes a full circle, so if I subtract 160, I've got 200 degrees left for my circle. So that means this arc's 200, which means angle, because it's a tangent and a chord, is half, so it's 100. So angle 6 is 100. Super easy. Let's keep moving on. Okay, here we go. No, we can't because I can't move the darn thing. Okay, so it says the angle formed by a radius or a diameter and a tangent is, guess what, folks? How much is half a circle? Half a circle is 180. That means if this arc up here is 180, that angle that is formed by the tangent and the diameter has to be 90 degrees or it's right. I'm so excited. It's a right angle. So look, I know this arc is 120. So that means this is 60 degrees because it's got to be half. But now to find angle 4, there's a diameter there. And so that means this tangent and diameter have to make 90. So look, this guy has to be 30. Super fun. Tangent and chord, half the arc. Remember that. Okay, moving on. 2 chords crossing. Uh-oh. And the chord is not a diameter. See how it's not going through the center? This is super fun. When 2 chords cross, it's half. The only time things are equal, remember, is if it's a central angle. So we're still taking half. But this time, say I'm trying to find this angle X here. Well, I'm going to add up its 2 fun arcs, BE, and I'm going to add its other arc on the other side. Because remember, these guys are vertical. So there's another arc over here, AD, that I'm going to add together. So it's half the sum of the 2 arcs. When 2 chords cross in a circle, it's half the sum of the 2 arcs it intercepts. Okay, so if you want the full written out version of that, it's in the note sheet. So I'm looking for angle 1. So I'm going to take half of its 2 arcs summed together inside. of 92 and half of 92. That's some big math. I gotta look on my answer sheet. It's 46, people. It's Mother's Day and I don't feel like thinking. Okay, here we go. We've got half. Oh, watch this one. See, it's right here. That's okay. If I find one of these guys here, because they're vertical, I can just use their supplementary effect. So I'm going to take half of 50 plus 66. So half of 116 ends up giving me 58. Okay, now that's not the actual answer because I need that angle next door, because I basically just found these angles here, which are 58. And so now if I go 180 minus 58, the guy next door is going to be 122. So the answer for angle 5 is 122. That's supplementary facts. Okay. What if they give me the angle and ask me for one of the arcs? Can I work backwards? Heck yeah. Okay, so I know the angle is equal to half the sum of the two arcs. So if I take 70 and make the other guy x, I can figure this out. Now, I could take and use 1/2 x. I could distribute that half to the 70 and to the x, but I'm going to get rid of the half by multiplying both sides by half. So 170 equals 70 plus x. Basically, I times this side by 2 and times this side by 2 to clear out the fraction. So when I move the 70 over, x is 100. So that other arc has to be 100 in order for those to add up. And the last example, same idea. I'd take 26x minus 2, and I'd set it equal to half of the sum of 131 plus 18x plus 1. And I would then encourage you to look on your actual note sheet so you can figure that one out. It ends up being 102 for the angle that is there they're looking for. You can look on your note sheet though. Since there's 3 pages to this note sheet, I'm going to move on, and everybody's attention span is probably like 5 minutes at this point in life. Okay, so now those were 2 chords crossing in the circle. These are 2 secants. Secants come from the outside of the circle, an external point, and go to the inside. They cross through the circumference in 2 spots. Now, instead of adding, so say I'm trying to find this angle that's out here, instead of adding the 2 arcs, I'm actually going to, guess what, folks, subtract them. And before, the adding didn't matter which arcs we're in, but this time it does. You're going to take the arc that's furthest away and subtract the arc that's closest. Okay, so here I go. I'm finding angle 1. It's half of the arc that's furthest away minus inside. So half of 40 makes the angle 20. Let's try to find an arc given the angle. 20 equals half of 70 minus x. Again, I don't like to work with a half, so I'm going to multiply both sides by 2. 40 equals 70 minus x. If I move that over, negative 30 is negative x, but don't worry, it turns into positive 30. So the arc is 30 on there. Not bad at all. Woo! We got one more example here. It says intersection of 2 tangents rule. Same idea as the 2 secants. The tangent comes from the outside place, except this time you're actually only touching the circle in one spot on the circumference. So each of the tangents touches in one spot. Again, you're going to take half of the 2 arcs subtracted. So if you look down at this example here, I'm looking for angle 3, and you're probably like, shoot, I have so many unknowns. But don't forget that a circle has 360, and if you know one of the arcs on the outside, that other arc on the inside here is really 140. So it looks like there's not enough info, but there is. Minus 140, which is really half of, I don't know, oh God, help me, half of 80, which gives me 40 for my answer for that angle. Super fun. Now look at this next one. They give you this angle that's in the center. And where if that angle is 117, so is this arc. Now I can do 360 minus 117 to give me 243. That's this arc here. Okay, now since it's on the outside and I'm looking for the angle outside here, I subtract 243 minus 117, which is half of 126, just 63. Super fun. So the bottom has a whole bunch of mixed practice examples, and I highly suggest you look at the answer key to check those out. If you have any questions, there were a lot of different angle types there. Basically, if the angle is on the outside of the circle, you're going to subtract their difference of their arcs and take half. And if the angle is on the inside and it's formed by two chords crossing, for example, these here, you take half of their sum of their arcs added together. All right, hope you have a great week, guys, and enjoy your homeworks. Bye. Later.